All right, hello, I'm Tim Leavitt. I'm the Development Manager in Application Services at InterSystems, and I'm joined by Gerrit and Stephan from TriFour to talk about isc-rest, a library that InterSystems has developed and released open source for rapid, secure REST API development. We'll talk a little bit about REST in general and the different approaches available that just come out of the box with Iris for building REST APIs, and then a little bit about some risks and pitfalls, especially from a security perspective, that you can fall into when you're building APIs and REST APIs specifically. TriFour will share their experience with isc-rest, and I'll talk about what my team's doing, and we each have some demos to share. So I'm curious, who here is using REST APIs right now in Iris? Who is still using Zen or CSP? I'm raising my hand too. Great. All right, so we're already on the right track there, I think, generally. So this is not news for many of you. If it was news, you probably wouldn't be here. What is REST? Stands for Representational State Transfer. Really basic ideas are using HTTP to access and manipulate data or resources directly. Resources have representations, which are most often in JSON. URLs should make sense for the resource that's being accessed. And you should be using HTTP verbs, get to retrieve data, put to save data in a way that's safe to do over and over again without additional side effects, so not making a purchase on Amazon. Post for things like that purchase on Amazon that you don't want to do 5 times, and delete to delete something. And these should match the operation that's being performed. And REST APIs should not rely on state. So in the case of ObjectScript, that would be %session if you're used to a CSP context. And in general, the contract for interaction between your client application, web or mobile application or otherwise, and the server, Iris in this case, we're assuming, and the API, that is to say the API to your data in Iris, needs to be well defined. If you are still building applications on our older user interface technologies, it's really not. The API is muddy, and that opens up security risks and just makes things harder to move forward as user interface technology continues to advance. From the show of hands, I think we're, as a whole, on a better place as the people in this room than we were when I talked about some simple a couple years ago, and that's really great to see. REST is industry standard. It can give you that well-defined contract, and Iris supports it pretty well. So you're using Iris. How do you build a REST API? There are 2 out-of-the-box approaches. The first is to just create a class that extends %csp.rest, override an xdata block that is the URL map, so defining what the different paths are to resources accessible through that REST API and the methods for interacting with them. Point to some methods that are called when you hit that route, and then hand code them. That's a lot of work. There's a lot of code that you need to write. A newer approach that is better than that is to start out by creating an OpenAPI specification, which is a structured way of saying this is the shape of our REST API, the data that it returns, the data that it expects, and then you can have Iris turn that into some classes. The generated code has some good standardized validation and error handling. You do still have to hand code implementations. You might still need to reference %request and %response, and there still is a lot that's up to you to make sure that you actually meet that contract. Either way, security will generally be handled separately from the specific resources and representations being accessed. So I'm curious, of who's using the first approach right now, hand coding REST APIs? Who's using spec first? Great. I feel like that was fewer hands than were using REST, but that's okay. So in my opinion, which is why we're here talking today, isc.rest is generally better than either of these approaches. For more information and all the documentation, you can see github.com/intersystems/isc.rest, and that links in the slides in the app too. Why is this great? It's really easy to REST enable your existing persistent classes for CRUD operations, that is create, read, update, delete. Also for a standard interface for running queries against an entire extent. There are also standard approaches to exposing business logic, say a method or a class method in object script, or class queries, which are a common way of wrapping access across a number of records. And there are some standard approaches to baking these in. All of the serialization and deserialization code for saying my API returns some object is, or my API expects some object is generated, so you're not hand coding that. The security handling is close to the resource or representation being accessed. And critically, you can generate an open API specification because of all of this metadata that we have in object script that fully describes your API and how to access it. And from that, you can even generate client code. And that's what we'll see in a demo later. So stepping back a little bit, what can go wrong in an API and what do we need to be careful about? The Open Web Application Security Project has a top 10 web application security vulnerabilities and a separate API top 10 that they just updated last year, actually. It's really good reading that I would recommend. And there are a lot of things that can go wrong systemically or in edge cases in these APIs. Number one is broken object level authorization. So you have a URL that has an ID in it, and you're not checking, does the user have access to that ID, for example. Broken authentication, if you end up rolling your own authentication, it's very easy to do things wrong. Broken object property level authorization. So this is, if you're familiar with the earlier version, this wraps together a couple things where you can users on input can either assign values to properties that they should not be able to with their level of access, or see values of properties that they are not able to with their access. Unrestricted resource consumption is really just you need an API manager to make sure that people don't spam your API. Broken function level authorization is similar to object property, really more around business logic flows. Unrestricted access to sensitive business flows is a new one that's really around making sure someone can't like buy out all the stock. It's really business logic specific. Server-side request forgery is tricking the server into making requests on the user's behalf with the server's level of network access, which allows for movement through a network. It's a rising vulnerability. Security misconfiguration is really a catch-all for a lot of things. Improper inventory management is we don't know what exactly all our APIs are. And they also added unsafe consumption of APIs, the fact that we tend to trust APIs that we're calling more than we should. So isc-rest, which we'll go into more detail on, helps mitigate some of these risks. Not all of them, but some of them and some of the really important ones. It puts the security considerations around access to specific objects and IDs close to the code that defines those objects. And because we can end up generating that open API specification, we know what the object property level, or we know what the properties are of the objects, and there's strict enforcement over that and strict alignment between the open API spec and what's actually supported on the server. There's also standard security configuration out of the box that we can help with. And because you can generate that open API spec, you know what all of your APIs are. Really key point that I want to make is that having structured complete documentation for your API, whether that's the start of building your API or an outcome of building it, goes a really long way to help with security, because there are scanners that will look at that. You can just see yourself, if you can read OpenAPI, what exactly the API can do, and red flags can pop out in a way that they won't if you've just hand-coded everything and it's sneakily working under the hood. So with that, I'll hand over to TriFour to share their experience with isc.rest, the things that they've done, what they do as a company.
Thanks, Timothy. My name is Gerrit Henning. I am the CEO of TriFour. We're a South African-based company. So I'll tell you a little bit about ourselves. Two things. We've got two business units, really. The first one is we have a product that we've been developing since the early 2000s. It's the TriMed Health Information System. It's widely deployed in the SADC region. So we were one of the early adopters of InterSystems technologies in South Africa way back in the 2000s. And we've come from MUMS to Cache to IRIS all the way through. So now we have a good install base for our product. And then recently, about 3 years ago, we started a professional services unit that specialize in InterSystems technologies. So we've built a good client base in South Africa, but also elsewhere. Our clients are actually, InterSystems themselves. They make use of our professional services, and then companies in South Africa like Mediclinic and NHLS, and then of course our own TriMed user base. So about the professional services, we basically offer 3 streams of services. The first one is interoperability. We've got lots of skills in that space, the standard protocols that we all use in healthcare, but also to integrate to the financial sector. And then we develop apps, web-based apps and mobile apps, and predominantly information management solutions. That's the middle tier there. And then we provide ICT operations, managed services, and monitoring of infrastructure, again, around InterSystems technologies specifically. So a little bit about what we do. But back to the use case that we're here for. I stumbled on isc-rest when it was still apps-rest on the InterSystems community portal, because I was looking at how to use REST, and the 2 approaches that Timothy explained up front seemed tedious both ways, and found apps-rest and basically started experimenting with that. And it later became isc-rest that we know today. So the first application we built with isc-rest was what we call the TriFour service desk application. It's implemented now as an incident management solution across the 140 organizations that we serve, managing multiple products, and manages the SLAs on all of those and making sure there's compliance. It manages the consultant workflows, how people interact with the system and with their customers, and it provides real-time feedback to customers. So that's a little bit about what it does. The technology stack itself, we use InterSystems IRIS for both application and database servers, and we use Angular. This product is now an Angular version 7. It's a single-page application with some responsive design technology. And as far as the architecture is concerned, it's a completely isc-rest API-built application. So the only way we use to deal or to interact with the backend is through isc-rest. We're not using any other mechanism. It's stateless. We've built our own token-based security model where it can easily be replaced with something like OAuth 2, any of those, or JSON tokens. And then we make use of a little bit of client-side caching to make the user experience a little bit better. So that's the kind of highlight around the architecture. I'm going to hand over to Stephan. We'll take you through effectively the process of building an application like this with isc-rest.
Hi, so I'm Stephan Plooy. I'm the CIO of TriFour, and I would like to just take you through the steps that we follow to build the incident management application that Gerrit spoken about. So we decided to take a data-first approach, which meant we started with the IRIS backend development and worked our way up to the UI. So the steps that we followed is, as initiation, we designed the data model as a first step. and then created our own isc-rest handler class. And that's basically a generic class that just extends the isc-rest handler. And you need to do that to have an API in your application. And then lastly, you create a class to extend the isc-rest authentication. And this allows you to implement your own authentication strategy. And as Gerrit mentioned, we opted for a token-based authentication strategy. So the next step will then be to create your persistent classes in ObjectScript. That's basically implementing your data model and business logic. And the two main classes from isc-rest that we used for this is the model adapter and model proxy class. And I'm sure Timothy will talk a bit more about that later on. Second thing you need to do is you need to override the check permissions function. And this allows you to specify permissions for each endpoint in your API. And then basically a result of this is as soon as you compile your persistent classes, your classes are automatically exposed as a REST-enabled endpoint. So the last step in terms of the backend development is then to auto-generate the Open API specification. And there's a built-in function we used for that. It's called console build Open API documentation. You run this function and it will build the Open API specification for you. Okay, so this is just an example. The output of that previous method call would be this Open API specification. As you can see, it will automatically take each persistent class, expose that as an endpoint, as well as all the actions and queries that you might have defined in that class. So these are just a couple of examples. Okay, so then we basically moved over to the UI development. So taking into account that we have the Open API specification now, the first step was to generate the Angular services and models from that Open API specification. So we use an NPM package called Open API Generator. You point it to that Open API specification, and it then actually generates the Angular services and models for you. So as you can see on the right-hand side screenshots, it will create an Angular service for you for each endpoint, as well as the input and output models to be used. So the last step to create the Angular application code, this is actually the first point where you do real development in terms of the UI. Up until this point, everything was automatically generated. Now you just implement the services that you generated and you basically develop the application and you implement the TypeScript models. Okay, so I just want to go through the benefits that we saw in isc-rest. So the main benefit for us is the propagation of changes from your ObjectScript class all the way through to the API layer to your client model and service. This is really an important benefit because if you make a change, there's no handcrafting involved. Everything is generated up to the Angular service and model. This saves a lot of time. It's less error prone because there's no manual intervention needed. And it's always in sync because of the auto generation. So if you make changes to your backend model, you do the generations and everything is in sync. Another benefit is that isc-rest supports actions and queries, and this enables us to use business logic. So we wanted to implement our business logic in Iris, and through using actions and queries, you can do that. And that's then exposed through the API as well. And then lastly, the security model is inherent. It's not an afterthought. So this is really an important one as well. Security is built into your API right from the start. It's not something you need to add afterwards. And I think at this point, I would like to hand back to Gerrit, who would do a very brief demonstration of the product that we developed.
Thank you. And after this morning, looking after all the AI stuff, this is going to be pretty boring, but it's only 3 minutes. It's pre-recorded. Not much can go wrong, hopefully. And but it'll give you an idea of what it looks like. Here we go. So normal login. Like I said, it's a single-page application. It's making use of Angular material. So we built in, the normal things to be able to change themes, etc. The account manager, And then this is a pretty busy screen. It sets up the organization that's going to be managing all of the SLAs, etc. So even though it's a fairly busy screen with lots of tabs at the top and steps to follow, it would still act pretty decently when it changes the screen size. That's what I'm just trying to show you. So I wouldn't necessarily use it on a phone, but certainly it could go to a smaller form factor quite easily. Still be able to update your record, submit it. I've actually used it on the phone. Some of our consultants look at calls on their phone without having to build a web app. So you could see it's steps within tabs, etc. Submit it, and if we just go back to the normal screen size, you'll see at the top there, you know, once you've dealt with the organization, you can set up the SLAs offered by the organization, the various parameters around that, the product supported, the systems that's involved, easily get to your users, modify a user, maybe interact with the screen on that basis. Look at the subsidiaries of the organization that you're dealing with, look at the clients, look at the clients in terms of their groups. If we log out and come back, that was an administrator. If you come back as a consultant, takes you to a different view where you just see all the active tickets. You can filter on a ticket, basically any type of text within the ticket. And then you can go and filter on each of the content, on each of the columns. If you're looking for a particular consultant who owns this ticket for a particular severity, and then it is still reactive from the perspective it doesn't act like a client server app. It's responsive. It's quick. Looking at the ticket, managing the ticket, showing attachments that users may have presented, looking at the actions, the workflows between one consultant and the next, looking at the details of the tickets in the right-hand corner in a sort of a quick fashion. And then the ability to duplicate the dashboard or any other screen for that matter. If you want one consultant, two views of the dashboard, just creates the duplicate one. In this case, you may only want to show the dev tickets that still has outstanding information from the client, for example. All right, so that's the application built on isc-rest, and thank you to Tim for the technology. I'm going to hand back to you. Thank you very much.
See that isc-rest supports building a very large, complex application with complex data as a. I'll talk about what my team's doing with it, and then we'll go into a much simpler demonstration of making a full stack change in about a minute of coding effort. So my team, InterSystems Application Services, is responsible for about 16 internal and some externally facing applications within InterSystems, all built on InterSystems Iris, ranging from over 20 to less than 1 year old. We maintain 8, I think, Iris-based open source projects, including IPM, which is new to us. I talked about that in the last session, and we'll kind of touch on that in what we're going toward. An extension for doing source control with Git that Ben and Praveen, also from Application Services, will be talking about tomorrow. The isc-rest and a backing JSON library, a package for doing test coverage measurement in ObjectScript, and if any of these things sound really interesting to you, feel free to catch me at the social event or tomorrow. I'm happy to talk about any of them to no end. So in terms of my team's use of isc.rest, at this point, 14 of our 16 applications, even the 20-ish year old one, are using isc.rest or its predecessor library on some level. Either the whole application has been retrofitted to use it, or the whole application was built with it from the ground up, or we're just using it for some internal data services. And this gives us a lot of consistency across the application portfolio. If you've seen one, you've seen them all, and it makes it really easy for the team to work across these applications. So we'll look at a full stack application that is using isc-rest and OpenAPI with client code generation and what this looks like in action. So for context, the application in question is docs.intersystems.com/upgrade. It's a new thing we released last year that provides an upgrade impact checklist, so you can pick a version of Iris that you're going from and to and see what you need to be concerned about on upgrade. The user interface is with Angular. The backend is, of course, Iris with REST APIs. It's defined and installed using InterSystems Package Manager with dependencies on isc.rest, which we're talking about, and another of our packages, isc.ipm.js, that handles Angular integration and the client code generation for Angular. And we'll demonstrate making a meaningful full stack change with less than a minute of coding and a little bit of extra time to explain what's going on. The code for this is not open source, but just as a pointer, there's an application with a similar architecture and infrastructure that you can look at that we also own. And if you find me on the Open Exchange, you can get to all of these things really easy. So of course, first thing we need is our REST handler. This would normally extend %csp.rest or come from the spec first approach. In this case, we extend %pkg.isc.rest.handler. We define our authentication strategy, which is we just let Iris do the work in this case. We say which resources, which are defined in classes, are accessible through this API, which is everything in a particular package of classes. We say that our user resource, our representation of who's the current user, is ultimately just a wrapper around username set to $username in Iris. But you could extend this with your own application-specific user concepts outside of the Iris security users. In our resource classes, you would extend %persistent, and for the simplest case, this adapter class that says this is a persistent class that's accessible over REST. There is a resource name parameter that you override to say what is the top level name of the resource, like organization, for example, or in the case we'll look at, change, that is right under the API and the URL. By default, from a security perspective, you can't do anything with that just by doing that. You need to override the check permission method and say, and all of this is documented in GitHub. You need to override this method to say you are allowed to create, read, update, delete, query, or perform certain actions on these records. And that has the user context, which we talked about previously, available. You might do a $system.security.check or look at your own application's user concepts and permissions. There's a pointer to the full documentation and more examples which do not fit in this format. So here's our motivating application. This is the InterSystems upgrade impact checklist. And is the video running? Yes. So you can pick different areas of Iris that you're interested in, generate a list, and I can see right at the top there's this change new super server. And suppose that we know that this is, here's our motivating use case. We know that this has been somebody and we want to highlight it in the user interface. That means we need to add a property on the back end, we need to do some UI work, and we need to handle all that messy stuff in the middle. So let's look at how we would do that. Here we have our persistent class. We can see it extends PKG isc-rest model adapter. We're going to add a new property there. You can see the resource name is change. So we're adding this property highlighted. It's a Boolean. We'll default to 0. So we'll just compile that. We'll run an SQL statement to say one of our changes in that table is highlighted. Then we'll go right over to our Angular UI, and this is running via ngserve, so our updates are reflected in real time. So I'll go into the package manager shell, and there was that console build open API documentation method with a really long name that was mentioned. This is a wrapper around that in the InterSystems package manager to say, regenerate the open API spec and regenerate the client code that is derived from that. So it takes a minute. When it's done, we can see we have openapi.json, and in our model for the objects that the API uses, we have a new highlighted property of type Boolean. In our TypeScript interfaces for things that could be in our query request against this table, we have highlighted as an option. In our model for input of a new object, which we don't actually use or allow access to, but we generate it anyway, and for output, we have a Boolean highlighted property. And this is all auto-generated. You don't need to go add the same thing in 15 different places. It's done for you. So now we can actually do the fun part. Here's in our Angular UI where we output that list of all the changes. We want to make this yellow, so we'll add a CSS class that says our background color is yellow if we have the class highlighted. And then we'll add that class to our div that has the change listed. So we'll say, we'll add the class highlighted if the change in question has our new highlighted property set to true. And we'll go back over to ng-serve. We can see that it compiled, and when the browser comes back up, that line is highlighted now. So we made a full stack change in Iris with a data change in Angular in about a 2-minute demo. It's not as cool as ChatGPT, but it still is, I think, really enabling, and we found it very enabling for our team to be able to adapt quickly and to build full stack on Iris much more quickly. So with that, we'll move to questions. Yes, that's a great question. So the question was in that changes section in VS Code, and that was a recorded demo, so it's hard for me to go back to it. It was showing changes made in Iris and changes made in the Angular UI. In this setup, we have we're not actually using Git, but if we were, we would have a single repo that has both our Angular UI and our Iris level code and has automation around managing all of it, which we found is simplifying from a development perspective to be able to work on everything in one place.
That's a great idea. We have them separate, Roland said that having them in one project very tightly couples everything together, right? So you don't make mistakes, and
Yeah.
you have it all in one branch, both the Angular code and the
Yep. Within InterSystems, we do it both ways. There is perhaps an architectural benefit from decoupling. In my team's case, it's the same people doing everything, and we tend to make changes in tandem between the APIs and the user interface that relies on them, so it's helpful to have it all together.
And then do you have a pipeline that pushes that, say, to a different environment, say for the QA people to go in and double check what you did?
My team sort of does our own QA. We do have automation around the Angular build and support within that isc.ipm.js package for automating Angular build and deployment as part of an Iris-centric project using the InterSystems package manager. I'm happy to go into more detail on that with you in future conversation. Yes?
So if Iris is responsible for creating the JavaScript and TypeScript,
Yep.
do you have access to the lifecycle hooks, like if you wanted to implement like a Redux store or something like that?
Oh, did you want to answer?
It goes up to the model and the server. So the
UI and using the Redux or the RxJS classes, you'd still have to, you still have to code those.
Yeah. Okay. So you could manually implement a store, but have Iris responsible for creating the models.
The models as well as the services that you interact with the HTTP requests. Yeah.
Other questions?
Does isc-rest help with when the version of the API changes?
That's a great question. Does isc-rest help with when the version of the API changes? There are two approaches that isc-rest supports for API versioning. One is to do the versioning using a media type, which you can override via class parameter in your resource class. So you can have multiple classes that define different representations of the same resource within Iris, and you can give them different media types and differentiate that way. Or you can have multiple classes that define different representations of the same resource and use the approach of having a V1, V2, and so on. And in your, if we go back a couple slides, in your check resource permitted method, you would say, for the V1 REST handler, these are the representations, the specific classes that are the V1. And maybe for V2, it's mostly the same, but there's a different one. And if you're going to go deep down that route, you might want to add some additional, more application-specific concepts on that. Or if everybody wants to go deep down that route, file a GitHub issue. Any other questions?
Yeah, so you mentioned one of the links is to a source which we can learn how to use or just by reading it. How about the first application? Is that something that is proprietary to
It's the source code is proprietary. You can see it in action. If we go over to this is another of my team's open source applications that uses the same pattern. isc-rest is another of, it's just a simple user interface around the line-by-line monitor. And the line-by-line monitor, turning it on, turning it off, starting it, looking at certain things, those are not CRUD operations. They're more complicated business logic. So that's a good sample of how you would wrap more complicated business logic in isc-rest. In the isc-rest GitHub repo itself, there is a user guide and a tutorial and sample application that help you get started with the basics. All right, thank you for your time. We get a couple minutes back to get ready to go to the Smithsonian.